All right, well, let's wrap this lesson up. Let's go to example number 12, which is number 46 in the book. It's actually number 46 is falling on page 296, okay? So I've already kind of written out a little bit of a little piece of what they've given to us, but obviously this does not make sense by just looking at this little thing, so we have no clue what they're even going to ask us. Once you pause this real quick, let's look at number 46 and pick up right here, okay? All right, so with this example, it basically looks like we have Cinema Center has 4 theaters. So if you want to think about it maybe as 4 screens, maybe we can make it simple as that. Or 4 individual, movie theater screens, okay? And specifically what this table A is talking about, as it tells us here, is the attendance for the Sunday matinee is given in this matrix. So if we look we talk about here in row 1, it means that the first movie theater basically had, on that Sunday afternoon, in that matinee, whatever movie it was, there was 225 children attended, 110 students, and 50 adults. If we go over to number 2, row number 2, it says then that cinema number 2, so the second theater, had only 75 children, 180 students, and 225 adults. If you go down here to number 4, since there were no children, but 250 students and 250 adults, I bet you it was like something like rated R or something, obviously, because no children were available at that one. Okay. And then if you go to the problem, it says, first of all, you want to write a column vector for B. Well, vectors, this is a new word we haven't really talked about before. Anytime your matrix is either just one row or just one column, so it's just one row with a bunch of numbers, like a 1 by 7, then if it has just one row, they refer to it as a vector. Or if it has just one column, let's say a 5 by 1, then that's going to be also a vector. So if you ever have just a single row or just a single column, they usually call them vectors. So in this case, since it's going to be a column vector, it's just going to be one column up and down. And it wants us to write a column that B is going to represent a column vector, specifically the admission prices. Okay, well, the admission prices for children is $4, $6 for students, and $8 for adults. So how can we write this out? It's like, okay, so here's my column. It says the prices are 4, 6, and 8. But let's actually label them out. It's like, what did this first one represent? Well, that was children. Then it was adults. And then it was students and then adults. Let me take that away for just a second. So we get this all listed together. And adults. I'm going to kind of abbreviate them. Okay. And then coming down this way, this is just basically dollar amounts, right? So the child tickets were $4 per child, $6 per student, and $8 per adult. All right. So let's go to this problem. It says we want to find AB, and then we want to finally find the total revenue collected at the Cinema Center for admission that Sunday afternoon. Okay. So if we're going to find AB, let's first of all, can we find AB? Is it legal? Well, the dimensions of A is a 4 by 3. We have 4 theaters and 3 type of people. So that makes sense. If we go over here to B, the dimensions of B is a 3 by 1. Remember the 1 being that whole vector part. So we have 3 types of people attending, but only one column to represent dollar amounts. Okay, so since the number of columns matches up with the number of rows over here, our resulting matrix is going to be a 4 by 1. So something with 4 rows and 1 column. So let's give ourselves some blanks here. 1, 2, 3, and 4. So something with 4 rows and 1 column. Okay, so now we have to actually multiply these together, and let's see what we get. And just like we did before, let's go position to position. So this first guy right here is obviously always going to be, it's going to be each of these first row to first column. Well, here's my first row right here, and we only have 1 column. So all I'm going to be doing is taking turns multiplying each of these rows by that 1 column. So in that first case, it's going to be 225 times 4 plus 110. So I'm going along the row and then down the column. Along the row and down the column. Okay. And if we put all that in our calculator, 225 times 4 and 110 times 6 and 50 times 8, we'll get an answer of 1,960. Okay, so that's the element that's sitting right there, 1,960. Okay, so if we go to the next part below just says now we're going to be doing second row. So the 75, 180, 225. So we're going to take the first thing in that row times the first thing in that column, the second thing in that row times the second thing in the column, and the third thing in that row, that's a funky looking 5, but that third thing, which is 225, times the third element. Okay? And if we put all that in our calculator, then it comes out to be 3,180. So that's our next element. Okay? And if I do the same thing with the other 2 rows to that column, we're going to come out with 2,510 and then 3,330. Or 3,300, sorry. All right, so let me erase just a little bit of this because we need to interpret this now just a little bit more. What did we really just find? You know, what is all this stuff that's listed over here on the left? Well, let's check out our dimensions. Let's write this out. Where did all this come from? Well, when I went A times B, remember what gave me the dimensions of AB was the number of rows over here and then the number of columns. Well, the number of rows were the Cinema 1, the Cinema 2, Cinema 3, and Cinema 4. The column was our money column. So when I've multiplied A times B, what it's telling me is if I look right here at this 1960, that means that when between all those children, students, and adults that attended at Cinema 1, that the grand total, what they grossed for that cinema, was $1,960 for that Sunday afternoon matinee. Cinema 2 grossed $3,180 between its, 75 children, 180 students, and 225 adults. If I look down here at row 4, that means they brought in the most money. So whatever was showing, it was definitely more beneficial for them to show like a rated R movie and not have any children show up, because it was better off getting the 250 students and the 225 adults because their tickets are worth more. Okay, and they brought in $3,300. So the last question says, find the total revenue for all of Cinema Center. So we're going to add in the revenue of Cinema 1 plus Cinema 2, Cinema 3, and Cinema 4. So if I add all that up, the 1,960, the 3,180, the 2,510, and the 3,300, we'll get for our answer then for all of this huge movie complex is $10,950. So that's what all was brought in for this on this one just Sunday afternoon matinee between those 4 different movie theaters, okay, or the 4 screenings. All right. Well, this kind of wraps up this last little bit here for part 4.2 and 4.3, where we're focusing on matrix algebra. And again, you'll be just responsible for knowing how to solve one matrice by hand, and then again by solving, I'm going to ask you to multiply 2 just simple matrices by hand again. So yes, I know that a lot of you guys can just plug this in your calculator because you've had practice with this before, but just be sure to be able to solve a 2 by 2 matrix by hand, and then, or a 2 by 3 where you're looking with 2 variables, and then being able to multiply 2 matrices together. So I'm going to have you do that by hand for sure. Okay?